Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by eDidik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Bismillahirrahmanirrahim. Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good evening to all teachers, parents and wonderful students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with eDidik Malaysia and Kelab Guru Malaysia. #bermula percuma, selamanya percuma. Before we proceed, let's begin our session with recitation of Kitab Al-Fatihah for the Muslim and a moment of silence for the non-Muslim. Al-Fatihah. So how is everyone doing today? My prayer that everyone is in the best health and ready to proceed with our class today. Before we start, let me introduce myself first. My name is Nun binti Muhammad Noor. All of you can call me Madam Nun. I am a physics lecturer in College Matrikulasi Negeri Sembilan Kuala Pilah, and I am your moderator for today's class. Okay, and with us here we have Teacher Sue as our expert host controller from SMK Sri Serdang Selangor, and our observer Teacher Hafsah Ayu from SMK Sultan Sulaiman Kuala Terengganu. All of us here are to make sure that our today's class run smoothly. And the most important actually, the person that will present, which is Madam Rosmaya. She is very experienced teacher. She is a very experienced teacher from SMJK Yuhua Kajan Selangor. So let us give a warm welcome to our presenter, Madam Rosmaya. So for the record, we are now live on Madam Rosmaya channel. So as a sign of support to Madam Rosmaya for the hard work in preparing today's class, please subscribe her channel, and all of you can also visit channel Teacher Sue, Teacher Hafsah Ayu and my channel to get a lot of physics learning material, and also not forgetting to subscribe to their channel too. And as usual, the lesson today will last approximately 1 hour. So the certificate link and the credit claim link will be given at the end of this session. Remember that you can only use eDidik email to claim the certificate. For credit claim, you need to collect the 1 letter and 4-digit codes, which will be announced separately during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. I would also like to remind all of you to use appropriate language and profile picture if possible, if you wish to post comment in the chat box. I'm pretty sure all of you here are excellent students who will uphold a positive classroom environment. Please give your full cooperation in making this live class lively. Stay focused, and if you have any question, please write on the chat box and we will try to provide you with the answers. Stay focused. Before I give Madam Rosmaya to present, this is a very important part. I will announce the first digit code for the credit claim. Okay, so the letter and the first digit code is A4. Okay, everyone, you get that? Make sure that you write something so that you not forget. So without further ado, Please welcome our presenter today, Madam Rosmaya, to start her presentation. Thank you.
So, I am Madam Rosmaya from SMJK Yuha Kajang, Form 6 teacher there. Okay, so before we start our class, our discussion today, so I would like to introduce, the prior teams in Academy YouTuber. Okay, so they are all together here. I want to show you the five teams, five prior teams in Academy YouTuber. Okay, so our physics teams, consists of me, Madam Rosmaya, as a leader. So all our members are here with us. So we have Teacher Sue, Teacher Sue on top of me, then we have Teacher Nun, below me as a moderator just now. And also physics teacher also, Madam Teacher Ayu, Hafsah Ayu. Okay, so all teachers here are physics teacher, and also we have Teacher Suhaya, not be able today with us today. Okay, next we have mathematics, Prayu, lead by Teacher Im. Okay, and we have biology, Prayu team, lead by Cikgu Faiza, and we have chemistry Prayu, lead by Cikgu Shahnun. Okay, and lastly we have Perakaunan and Ekonomi Prayu team, lead by Madam Fizi. Okay, so now we start with our discussion today. Continuation from the previous topic, alternating current circuits, part 2. So we are going to discuss on reactance and impedance. So this is the last subtopic, in the last chapter for semester 2 in Form 6 syllabus. Okay. Okay, so reactance in alternate current circuit. Okay, so what are we going to discuss today? Okay, we are going to discuss the definition for reactance. Okay, and then why it occurs primarily in alternate current circuits. And then we are also going to discuss on the difference between inductive and capacitive reactance. We are going to derive the formula for inductive and capacitive reactance, and also discussion on the effects of a change in frequency on inductive and capacitive reactance. Okay, so what is reactance? What is reactance? Reactance is the measure of the opposition to the flow of alternating current caused by the inductance and capacitance in a circuit, rather than by resistance. Okay, so the greater reactance leads to smaller currents for the same voltage applied. Reactance is similar to electric resistance, but it differs in several respects. So we are going to discuss why. So we are going to use these two circuits. Consist of alternate current passed through pure inductor, and another one is passed through pure capacitor. Okay, to discuss the reactance. Okay, and there are two types of reactance, inductive reactance and capacitive reactance. So for this circuit, involve capacitive reactance. And for this circuit, inductor pass through AC current pass through pure inductor. So it will experience inductive reactance. So inductive reactance is associated with the varying magnetic field that surrounds a wire or a coil carrying a current. Example, this inductor. And the capacitive reactance is associated with the changing in the electric field, between the two surfaces plates, separated from each other by an insulating medium. Okay, in the last week discussion, in the topic alternate current part 1, we have derived the formula of I, and we get starting with the V equals to V peak sine omega t. So we have derived I and we get this. I equals to negative V peak per omega L cos omega t. Okay, from here, okay, from these two, V and I, we get a graph, right, where shows how the phase relationship between voltage and current. From here, sine, for voltage is a sine graph, and for the current is a cosine graph, negative cosine graph. So this means that voltage lead current. Okay, and from this equation of current, okay, the negative V peak per omega L is defined as I peak. Okay, so we take this one, I peak equals to V peak per omega L. So the negative can be cancelled out. Okay, so we can define the reactance from here. Okay, cross multiply, so we get omega L per V peak per I peak. Okay, so V peak per I peak is called reactance. Okay, V peak per I peak is called reactance. So the unit is similar to the resistance, which is ohm. Okay, because ohm we get from V equals to IR. R is V per I. So therefore, this one will be inductive. Okay, this one will be inductive reactance. The symbol we use for reactive inductive reactance is XL. Okay, so this is called reactance of the inductor or inductive reactance. Okay, so omega is 2 pi F, so we can relate the reactance for the inductance here with the F. Okay, we put this I on top here. Okay, I erase this one. Okay, so now we are going to continue the reactance equals to V peak per I peak. Okay, compare with the V equals to IR. This one you used already, right? This equation is familiar to you all already in the Form 4, Form 5. Okay, so we can define XL as the reactance. Reactance, we call this reactance of an inductor is the opposition of the inductor to the flows of an alternate current and is measured in the units ohm. So same unit as this equation. So for XL, also the unit is ohms. Okay, so remember reactance is opposition to AC current. If XL through the inductor. Okay, the AC current flow through the inductor. Okay. In the previous lesson also, last week, we have discussed this equation, the relationship between RMS value and the peak value for current and for the voltage. So we are going to substitute the I peak and V peak here into this equation. So what we have? Okay, we rearrange the equation here. I peaks becomes Z2 times IRMS. Okay, cross multiply. Here also, V peak equals to Z2 times VRMS. Okay, so we substitute into here. Okay, so we can cancel out Z2. So the formula for inductive reactance, okay, the formula for the reactance for the inductor also can be written as VRMS per IRMS. Okay, so memorize this formula for the reactance for inductor. Remember that you must use the pair if peak with peak, V peak per I peak, and if VRMS per IRMS to get the reactance for the inductor, or another word, inductive reactance. Okay, so memorize this formula. Okay, I saw Azwan there. Okay, welcome Azwan. Okay, so those who are here can write there in the chat box to show that you are here with me with the discussion on alternate current, alternating current part 2. Okay. Okay, now we continue. From here, the graph, the relationship between reactance with the frequency. Okay, look at these two, how they relate with each other. So we can plot the graph, reactance X here against the frequency, F. Okay, so 2 pi and L is a constant. So therefore, relate with the linear equation. So we get actually it's a linear graph. Okay, from y equals to mx plus c. So the c is y-intercept is the origin. So therefore the gradient will give you the value of 2 pi and L. Okay, if you plot the graph reactance XL against the F. Okay, so we can say that reactance is directly proportional to the frequency. Okay, done for the AC through inductor. So next we discuss AC through capacitor. So we are going to derive the reactance for the capacitor. Okay. And also in the previous discussion, okay, last week, we have derived the current passed through the capacitor here in this circuit. So we get I equals to CV peak omega cos omega t. So this is equivalent to the equation I per I peak cos omega t. So I peak can be defined as omega C V peak. Okay, we take this one as a I peak. Okay, so you got this. Okay, and last week also we get the how the relationship of voltage and current for the capacitor in the AC circuit here. So we find that current lead voltage. Okay, current lead voltage. So cos is a cosine graph and the V is the sine graph. Okay, that one is the last week. So for this week, we are going to concentrate on the reactance. Okay, so from these terms, CV peak omega, so we get I peak equals to omega C V peak. Then we cross multiply to get the definition for reactance. Okay, so V peak per I peak is called reactance equals to 1 per omega C. So this 1 per omega C is the reactance for the capacitor. Okay, so the ratio V peak per I peak is known as the reactance of the capacitor in reactance in the capacitor. So we call this XC. The symbol we use is XC. Okay, so omega is 2 pi F. Okay, so you can substitute 2 pi F into the omega here to get the relationship between reactance of the capacitor with the frequency. Okay, so what's the graph looks like? So I erase this. Okay, first we define the XC, how to define in the statement form. Okay, compare with the V equals to IR. For resistance, V per I will be resistance, but V peak per I peak for this capacitor in this alternate current is called opposition to current. Okay, similar to the resistance. Resistance is also opposition to current. Reactance also is opposition to current, but it's opposition to the of the capacitor to the flow of AC current in this circuit. And the unit is the same as the resistance, also ohm. Okay, so now the graph. What's the okay? Before the graph looks like similar to the previous slide. Okay, we can also write reactance of the capacitance instead of V peak per I peak. Okay, we can also write as VRMS per RMS. Okay, so same equation, so it's easy to memorize. Okay. Okay. So next, we are going to plot the graph, the graph reactance against the frequency for the reactance of the capacitance for the capacitor. Okay, look at this graph. This graph is 1 per 2 pi FC. XC equals to 1 per 2 pi FC. So 2 pi and C is constant. So that means the shape of the graph is the hyperbolic curve. Okay, because it's inversely proportional. Reactance is inversely proportional to the F. Okay, so the shape of the graph is a hyperbolic curve. Okay, so reactance inversely proportional to the frequency. Okay, now we can combine both graph. This is the graph of reactance of the inductor against F. And another one, hyperbolic curve here, is for the reactance of the capacitor against F. So we combine both graph, they intersect at this point. Okay. And for the resistance, Okay, in the AC current will give a constant value because it's a resistance, a constant value, because the V and I are in phase. So they are, so that means the R is constant all the time because V and I are in phase. Whereas the reactance for capacitor and inductor, they are not in phase. So that's why the shape of the graph is different from the resistor. Okay, so next we are going to discuss on impedance. Okay, so similar to resistance, reactance of capacitor and reactance of inductor, they are all actually a position to current, AC current. So for impedance, it is also a position to current. So impedance symbol we use Z is the measure of the total opposition to current flow in an alternating current circuit. It is made up of the sum of the two components, okay, resistance and reactance. Can be the unit also the same, is ohm. The unit also the same, ohm, because this is a position to current flow in AC current circuit. But in the circuit, it consists of combination of resistance and reactance. Example here, resistor and capacitor in this circuit, in the series circuit here. So resistor and the inductor in the AC circuit here, and Rcl circuit, resistor, capacitor and inductance, okay, in the circuit. Okay. Okay, I have question here from Azwan. Okay, madam, why the value of the peak voltage greater than the current peak? Okay, so actually we draw it on the same graph. Actually, you can also draw I larger than V, but it is not advisable. Okay, because the current, because from V equals to IR, how to say, the is the graph, the scale use actually different. Okay, the scale use is different. Okay, the scale use for is the same graph. So the V is voltage, so I is in ampere, right? So you cannot compare them actually. Just to distinguish between the V and I, so usually we draw V, the peak of the V is larger than I. Okay, actually we go, okay, I go back to the graph. Got
Madam
okay.
Rosmaya, can we give them the second code?
Okay.
Okay. So, students,
Um,
our second digit code, pay attention. Our second digit code is 9. Okay? 9. Okay. So please write down somewhere. Okay, thank you so much. So, Madam Rosmaya, you can continue. Thank you.
okay, so we continue. Okay, for the if you draw on the same graph, actually the scale is not the same, right? Voltage is for ampere, voltage is for volt, and current is for ampere. So actually, when you compare the two, usually we draw I less than the V, the V peak. Okay, and you will learn in detail for the graph actually when you further your study in the university. Okay. Okay, so now back to the impedance. Okay, so the graph we are going to discuss for the impedance, which consists of the sum of the components from a resistor and inductor or capacitor here, which is resistance and reactance. Okay, RC circuit, RL circuit, and Rcl circuit in series. So we don't discuss them in parallel. Okay, for the STPM syllabus, I don't know what about the metric syllabus. They are, we only learn, discuss for the series circuit.
Sama, only series circuit.
Series circuit.
Yes.
Okay, so we have also, we are lucky here, we have a matrix teacher also here. Okay, thank you Cikgu Nun for clearing the problems here. Okay, so now for RC circuit in series, we discuss this first. Okay, so you cannot add up the resistance or the impedance with the resistance here for opposition to current. Cannot because I and V are not in phase. So the total impedance is not simply the algebraic sum of the resistance. So inductive reactance and capacitive reactance. Okay, since inductive reactance and capacitive reactance are 90 degrees out of phase, okay, with the resistance for the capacitor, right? And therefore their maximum values occur at different times. Okay, vector addition must be used to calculate this impedance. So we are going to use a vector method to solve for the opposition to current. Okay, relationship, we are going to derive the relationship between resistance and reactance for the capacitor here. Okay, so back to the last week. Last week. Okay. I and V are in phase. Okay, for resistor, I and V are in phase. And then for capacitor also, we've discussed I lead V by pi per 2 radian. Okay, so we plot the graph. We plot the vector diagram. Okay, or another word we can say phase diagram actually. Okay, we refer to the current. Let's say a positive current is to the right. Okay, positive current to the right. So therefore, the V for R, resistor also to the right. Remember, I and V in phase, right? Okay, so VR follow the I, phase, same phase, so same direction. Then for capacitor, voltage of C is I lead V by pi per 2 radian. So therefore, the VC we draw downward. Okay, we draw down pi per 2, so that's mean we plot here the difference between these two is 90 degrees. Pi per 2 radians is they are perpendicular to each other. Okay, so the amount of voltage across the capacitor is represented by the length of the vertical line here. Okay, so pi per 2 radian, so draw perpendicular to each other. So what is VZ? So VZ will be, if we draw the parallelogram here, so it's the diagonal for the parallelogram. Okay, so the amount of the resultant voltage is called VZ, is represented by this line, the diagonal line here. Okay, so we use vector to solve for VZ. So VR and VC, we follow by the magnitude given if asked in the question. So VZ is the voltage for the across these two R and C. Okay, VZ. Okay, so the angle between VR and VZ is called phase angle. Okay, it's called phase angle. Okay, so the phase angle between voltage across the resistor VR and the resultant VZ here. Okay, so VR equals to IR, VC equals to IC. So instead of using the phase diagram for VR, VC and VZ, we can also draw the phase diagram using R, using the opposition to current, which is R, consists of R and reactance and also Z. Okay, why? Because the circuit just now is in series. So I is the same. Okay, current is the same because they are in series. So therefore, we can draw the phase diagram like this also. Okay. And we can use Pythagoras theorem to calculate for Z. Okay, so the Z is given by square root of R squared plus XC squared. Okay, from the right angle triangle here. So use Pythagoras theorem. So we have derived the equation for impedance, which is equals to square root of R squared plus XC squared. XC is the reactance for the capacitor. Okay, so Pythagoras theorem. Okay, then for phase angle, we can calculate also using trigonometric ratio. So we get VC per VR. Okay, VC per VR. opposite per adjacent. And from this second phase diagram, we can use XC per R. Okay, same, you will get same magnitude, same magnitude. Okay, same phase angle. You will get same phase angle for both diagram. Okay, so done for the RC circuit. Okay, so next we are going to relate with the frequency. Okay, so XC is equals to 1 per omega C. So omega is 2 pi F. So we substitute 2 pi FC here. And now can see impedance and the frequency. So what happened? Okay, what is the variation of impedance with the frequency? So it's not a straight line graph. So it will form a curve graph. For Z again F, if the resistance is we draw is a straight line because resistance all the time is constant, right? So we draw on the same graph as impedance against frequency because the unit is the same, ohm. So what happens if R increases? Okay, refer to this equation. So if I increases, so this value 1 per 2 pi FC will approach 0. Okay, if I increases, so this value 1 per 2 pi FC decreases. Or another word, will approach 0. So therefore, Z is equals to square root of R squared only. Okay, so therefore Z equals to R. Square root of R squared is R. Okay, so the Z will approach R for high frequency. So what's the graph will looks like? So it's a curve graph, decreasing graph because Z approaches R. So look at the x-axis here, frequency, right? So for high frequency, so the Z y-axis decreases, approaching resistance. Okay, not? So that's how you get the curve for the impedance against frequency. Okay, so we just sketch the graph from this by and do this analysis only. Okay, the specific value if you do experiment, then you can see clearly here. Okay, so now just the sketching only. Okay, we refer to this equation. Okay, so the graph I against variation of impedance with frequency. So the variation again I with the frequency from V equals to Iz. Okay, so if V per I equals to Z, right? So as F increases, so Z decreases and I increases. Because Z decreases, right? Here you see Z increases. So if Z decreases, what happened to I? So I increases. Okay, it's logic lah because opposition to current. Z is opposition to current. So its opposition to current decreases. So high will flow higher. Okay, so this is from 2-in-1 graph also. So the I increases as the Z decreases. Okay, and then we start here F frequency 0 because if I 0, it is as if the capacitor blocks direct current. Okay, so at F0, so that's mean I 0. Logic because steady current, the frequency is 0, right? Steady current. So direct current or steady current is 0. So frequency 0, I block the capacitor block the direct current. Okay. So
Okay, Madam Rosmaya. Would you like to take a break for a while for the advertisement?
Okay.
Okay.
Continue
So
later.
everyone, let's watch the advertisement.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus gancaran hebat ini sekarang. Layari www.academyoutuber.com untuk maklumat lanjut.
Okay, so we are back. Okay, so we continue with the impedance, still in impedance, reactance done, but this time impedance in the Rcl Circuit in series. Okay, so we start with R. I in phase with V. So for L, V leads I by pi per 2 radian. Okay, how to memorize this? I've given already before in the previous discussion last week. So you can use the word civil. Okay, so VIL, the vowel. So for L, V leads I. For easy to memorize, for faster, for quickly to memorize. So you can use the word civil. So now we plot the phase diagram. Okay. So we still use the same direction for VR initially. We follow the I direction. The I is in series, the I in series. So we follow I. So VR is the same direction as I because in phase. Okay, next for the R, because V leads I by pi per 2 radian. So we draw at the positive side. V lead I. So that's mean V on top. So pi per 2 radian, so that's mean you draw perpendicular with the VR. VL perpendicular to VR. Okay. Next, the VZ is diagonal line here, shown by the diagonal line here. Imagine you draw the parallelogram and use vector to solve for VZ. Okay, so you draw the parallelogram, or you can draw tip to toe method. Also, you get the same direction as VZ. Okay, so the phase angle is between VZ and VR. Okay, this is the phase angle. Okay, we can also use the second phase diagram using only the reactance and resistance and the impedance. Okay, Z, the impedance. Okay, same diagram. Okay, because I in series, I in series. So that's why you got same diagram. Okay, so next, from the Pythagoras theorem, okay, we can derive impedance. We can derive impedance, which is equals to the square root of R squared per R squared plus XL squared. Okay, or you can use also V actually. I didn't write here. Okay, so the VZ is given by square root of VR squared plus VL squared. Okay, from both diagram actually, we can use Pythagoras theorem to solve for impedance and also to solve or equation for the VZ. Okay, then for the phase angle, you can use VL per VR. Okay, from this diagram. And for this graph, phase diagram actually, from this phase diagram, so we can use tangent phase angle equals to XL per R. Okay, so next we are going to relate with frequency. Okay, so what's the graph looks like? Okay, XL is equals to omega L. Okay, and omega is 2 pi F. Okay, so now you can see the relationship between Z and F here from the graph, from the equation here. Okay, R is constant. Okay, R is constant. 2 pi and L also constant. Okay, what is the variation of impedance with frequency? So how to plot graph? So we just sketch. So we look for F. Is F increases, what happened to Z? Okay, so compare with the R here. Okay, R we know that constant. So you draw a straight line to represent R. So now if F increases, okay, Z also increases. Okay, F increases, Z also increases. So the shape of the graph will looks like this. Okay. So this is the, if you do experiment, you can get more the curve, the curve, you can relate the curve with this one. But now we just sketching only. So if F increases, so Z increases. So can see from the graph how the Z increases when the y-axis here F increases. Okay, and then at F equals to 0, okay, Z is equals to R. How to know this? you try to substitute F0 here. So this term will equals to 0. So therefore, go back. Okay, so therefore Z equals to square root of R and Z equals to R. Okay, so that's why you plot from the y-intercept here equals to the line where you draw the R is. Okay, when R equals to, when F equals to 0, F frequency 0, so Z equals to R. By substituting the F into the equation, so you can get Z equals to R. So this is the shape of the graph. Okay, as F increases, Z also increases. Okay, so now we've done for the RC circuit and RL circuit. Okay, so we get the relationship of impedance with resistance and reactance. Okay, reactance. Okay, so next we are going to discuss the RCL circuit. Okay, what if the circuit consists of R, C and L? Okay, so again, we start from R, I and V in phase. So C, I leads V by pi per 2 radian, and for inductor, V leads I by pi per 2 radian. Okay, now we combine all these in the phase diagram. Same way, we refer current to the right. So for the resistance, the V also to the right, because they are in phase, I and V in phase. So for all C and L, for all R, C and L, I is we choose this direction. They are in series. Okay, that's why we refer to the direction of I. So we assume I is to the right. Okay, so now for C also we do the same. Oh, we draw the VL first. V leads I, so VL is on top, perpendicular to the VR. And lastly, the C. The C we draw downward, perpendicular to VR, because I lead V by pi per 2 radian. Also perpendicular to VR. Okay, now combine all together lah. For in the phase diagram here, VL, VC, VR. Okay, to solve the vector here, so we do the vertical first, vertical VL and VC. So we get VL minus VC because VC downward. So upward is we take positive. So that's mean VL minus VC. Okay, combine VL and VC together. So we get VL minus VC. Okay, now we can forget about the VL and VC drawn just now. So we have combined them into one. Vertical vector is VL minus VC. Okay, so now what is VZ? VZ is the diagonal line here. Okay, you draw the parallelogram and the diagonal line here will give you the VZ using vector method. Okay, so this is VZ and the phase angle is between VZ against the VR. Actually from I current direction. So this is the phase angle. Okay, so VZ equals to IZ. Okay, so we can use the we can derive the equation for voltage for across RCL, all of them. Okay, so we name as VZ. Okay, the V across all of them RCL is given by VZ. Okay, square root of, we use Pythagoras theorem. We use Pythagoras theorem. So that's mean VR squared plus the bracket VL minus VC squared. Okay, square root. So we get VZ, or we can use, you can also derive Z from here. VZ is IZ, and then VR is IR, bracket squared. VL is IXL, and VC is IXC. Okay, so bracket squared. So you can cancel all the I here because they are in series. I repeat, I in series, so that means I is the same. So I squared plus here also factor out I squared. So you get square root of I squared is I. So you can cancel I both sides. Cancel out I, so you get Z impedance equals to square root of R squared plus bracket XL minus XC squared. Okay, so this is the formula we derive for impedance. Okay, so memorize these formulas because we are going to use this in the question later. Eh?
Madam Rosmaya, can we have a break? I just want to announce the third digit code
Okay,
for
can.
them. Okay. So to all students, our third digit code for the credit claim is 0. Number 0. Okay. All right. So you can continue, Madam Rosmaya. Thank you.
Okay. So now we are going to relate Z with F, frequency. Okay, frequency. So we substitute XL equals to omega L, XC equals to 1 per omega C. Okay. And then the omega is 2 pi F because we are going to relate with F, right? Z and F. Okay, so you get this. Okay, so what is the variation of Z and F? Okay, so for the graph, we just do sketching only. Okay, so R is constant. Okay, then this graph will looks like this. Okay, you can show this actually from the experiment, from the experiment. But the sketching is about like this. Okay, so the point here will give you the specific frequency. We call this as resonant frequency. Okay, we call this as resonant frequency. Okay, this F, where they point a sharp point here. For the graph, if you plot, there is a sharp point. So this sharp point will give you the reading for at the frequency here as F note. We call this as resonant frequency. Okay, so the resonance of a series Rcl circuit, this one occur when the inductive and capacitive reactance are equal in magnitude. Okay, equal in magnitude, but they cancel each other because of they are 180 degrees apart in phase. Okay, so this is where the resonant frequency is. Okay, so at resonant, the impedance of the circuit is purely resistive. Okay, purely resistive. Okay, so from this statement, if they are equal in magnitude, okay, so that's mean XL equals to XC, right? But they are 180 degrees apart in phase. From the diagram just now we've drawn already. Okay, so XL minus XC, if they are equal in magnitude, so what happened? This result the zero value from here because equals the zero value. So therefore the Z equals to square root of R squared and give you the R. That's why we say that at resonance, the Z is purely resistive. Z equals to R. Okay, so it touched the point of the R lines here also. Okay, equals to the impedance equals to resistance. Okay, the impedance equals to the resistance value. XL reactance is 0. Okay, cancel out each other. So that is where resonant frequency is. Okay, so the sharp minimum in impedance which occurs is useful in tuning applications. Okay, especially in making the circuit, in tuning circuit in the radio, for example. Okay, in example, the selection of FM radio stations by the radio receiver. This is where the calculation can be done to determine the resonant frequency. Okay, so if you further your studies in the electric electromagnet, so you will learn this in detail. Okay, so for at this moment, you just know the example of the application of the resonant frequency in this case. Okay, so the graph. Okay, we are going to derive this resonant frequency. Okay, so if XL equals to XC from this statement, XL is equals to XC. So omega L equals to 1 per omega C. So omega is 2 pi F. And this happened, okay. This happened at the frequency, resonant frequency, right? So we substitute this omega as F note. Okay. These two happen only at resonant frequency when they equals. When they equals in magnitude happen only at resonant frequency. So that's why we substitute F note here. Okay, then we cross multiply, we get F note squared. Okay, the 2 times 2 becomes 4 pi squared LC. So F naught is given by 1 per 2 pi square root of LC. So this is the formula for resonant frequency. Okay, just to derive only for the formula for resonant frequency. But actually no need to memorize also can. You just memorize from the beginning here. It's easier compared to memorize the new formula here. So you just memorize XL equals to XC at resonant frequency. That's all. So if in the question asks for resonant frequency, so no need to use this formula. Okay. So this is the derivation for the resonant frequency, which is equals to 1 per 2 pi square root of LC. Okay, so now we've done all for the reactance and impedance and the relationship with the frequency, impedance and with the frequency. Reactance also done already, and this is the equation for the impedance. And next we are going to do question. Okay, so hopefully we managed to do a few questions. Okay, we start with question 1. Okay. So what value of capacitance has the same reactance as 250 millihenry inductor at a frequency of 50 Hz? Okay, it's very simple question. Very simple question. Okay. We just finished discuss just now. So you can try to calculate. If you got the answer, can write there in the chat box. So the clue here is the same reactance. Same reactance. Okay, try and do. Okay, so the same reactance means X capacitance, right? An inductor. So that's mean XC equals to XF. Okay, XC equals to XF. Okay, so that's the clue. So what you get the answer? You can write there in the chat box. Very simple question. Just use XC equals to XF because it state their same reactance. So what is the formula for XC and XF? Have you memorized the formula? XC equals to omega L. Okay, L is Henry, the unit Henry. So given there. And XC equals to 1 per omega C, sorry. And XL equals to omega L. XC equals to 1 per omega C. And the frequency is 50 Hz. So you can calculate the capacitance. Okay, so we have one answer here already from Kao Min Chai. Okay, Kao Min Chai got 1.6 times 10 to the power of negative 3 farad. So the unit for capacitance is farad. Okay, so the rest of you can join. Write the answer there if you got same answer with Kao Min Chai. So you can use the straight. You can use the XC equals to omega L equals to XC equals to XL. Okay, so or you can straight away use the equation just now we've got. Okay, Valamati also got same answer with Gao Min Chai, and Gao Min Chai change answer already. Okay. So you can use two methods. As I said just now, you can equate XC equals to XL, or you can use the formula if you memorize the formula just now. Okay, so frequency here, it is understood that this is resonant frequency. Why? Because they have same reactance. Okay, because they have same reactance. So you can use the frequency given here as the resonant frequency. Okay, you cannot use this formula if the reactance not the same. Reactance for inductor and reactance for capacitor not the same. You cannot use this formula. Okay, but in this case, you can use this formula. Okay, so you substitute 50 Hz because this is understood that it is resonant frequency. Okay, then the millihenry convert to Henry, convert to Henry, and you can find capacitance direct from this equation, which is the answer is 4.1 times 10 to the power of negative 5 farad. Okay, so you can answer in 2 or 3 significant features. Okay, so 4.05, correct. Okay, so try next question. Actually, you can start from the beginning like this. I show you fast how to use another method. You know that these two are the same, so you can use XC equals to 1 per omega C. So F is 50. Okay, and XC you can get from the XL. XL is omega L. Okay, because you equate them, right? So L is 250 milli, convert to Henry. Okay, frequency also the same. Okay, resonant frequency, right? The same. Okay, so you substitute into here, this value, and you get the same answer. Okay, you get the same answer. So it doesn't matter. Okay, use the formula just now or use this method. Okay, so next. Question 2. Okay, alternating voltage given 5.0 sine 200 T volt is supplied to a solenoid of inductance 0.20 Henry. So what is the RMS value of the current passing through the coil? Okay, so RMS value, inductance given L, and then the alternate current voltage. So you must start from the beginning. What the hidden info we can get from this sign equation for V. Okay, so relate with the last week equation with proof RMS value and with the peak value. Okay, I give you clue already. RMS value and the peak value. The peak value can get from this equation. And also we can get the 2 pi f frequency from here. Sine omega t, so omega is 2 pi f. Okay, so many clue already given. Okay, so what's your answer? Always ready with your calculator with you. Every time physics class. Okay, so ready with your calculator. Okay, so RMS value equals to peak value per set 2. Okay, peak value per set 2. In this case is V, V peak. So VRMS equals to V peak per set 2. Okay, so for the V peak can get from the equation here. Okay, now to get, but we don't know what else we don't know. The question 1 RMS. Okay, what's your answer? Okay, I'm waiting. Okay, the clue just now, this one. Okay, so we have answer from Yong. Okay, 0.088 ampere. Gao Ming Chai, 0.014 ampere. So 2 different answers here. Okay, so which one is the correct one? Okay, from here, the V equals to V peak sine 200 T. Okay, Chia Che Chong, 0.09 ampere. Okay, Chia Che, same answer as Yong. Okay, so we can get V peak from here and also frequency. V peak and the frequency. So V peak is 5 and frequency omega is 200. So 2 pi f is omega. And L, we substitute, okay, L also we know here. Okay, so now I RMS equals to V RMS per XL. Okay, so RMS equals to VRMS per XL. How to know this? It's very easy. You are familiar with the V equals to IR already, right? Form 4, Form 5. Actually, from Form 1, Form 2, Form 3 also, right? V equals to IR. So just follow. If V equals to IR, so that's mean V equals to IX. So in this case, we use XL. So V equals to IXL. Okay, so very easy this formula to memorize. Okay, now RMS equals to VRMS. So VRMS, we can use this V peak per cert 2. Okay, so substitute the 5 here. And XL is omega L. So omega from this one is 200. Okay, 200. So you substitute everything into here and you get the answer 0.088 ampere. So 0.08 or 0.09, 0.088 lah better. Two significant figures because the data given here is two significant figures. So 0.88 is the best significant figures to write down. Okay, I think we can one more. We still got one more, a few more minutes. Okay, so we do this question. Okay, what is the reactance of the capacitor? Okay, a 50 Hz AC supply is connected to a capacitor and AC emitter. So CRO, okay, cathode ray tube, oscilloscope with a Y sensitivity set as 3 volt per centimeter is connected across the capacitor. So the trace on the screen is 6 centimeter long with the time base off. So the emitter gives a reading 2.0 ampere RMS. So calculate the reactance, okay, and the capacitance, okay. But this time is capacitor, so we use V equals to IX for C. Okay, but if you use V equals to IX, always use in pair. If peak together with peak, V and I peak. If you use RMS, I also must RMS. Okay, we derived this already. So V peak equals to I peak XC. If you want to use RMS, V RMS equals to I RMS in V. You cannot mix them. Okay, cannot mix them. Okay, frequency is given 50 Hz. Okay, then for the 3 volt per centimeter, so that's mean the 6 centimeter. Okay, so 3 times 6, so that's mean is 18 volt. Okay, 18 volts. Okay, this is 3 volt per centimeter. Okay, because we set the Y sensitivity. So the length, the trace in the screen is 6 centimeter. So that means 6 times 3, we get 18 volt. Okay, the reading here. 18 volt is from here to here. The Y sensitivity, right? Y. So the vertical one is 6 centimeter. Okay, so 3 volt, so times 6, you got 18 volt. So therefore, the V peak, you divide by 2, so you get 6 volt. So from the reading of the CRO, you can get V peak. Okay, you get V peak which is 9 volt. Okay, so after you get the V peak, so you can substitute into here. Okay, substitute into here. Okay, so now the current, the V peak, no problem. So now the current given here RMS. So you use formula I peak per cert 2. Okay, I peak per cert 2. So you solve this. So you substitute into here also. So you get XC equals to 9 per 2.8, 28. So before you come to final result, don't round off too early. Okay, you can use this, don't round off too early. And the final answer only you round it off. Okay, so you can write in two significant figures lah. Okay, two significant figures. So 3.2 ohm. It is better to write to 3.2 ohms. And the capacitance, okay, so for the capacitance, you can use XC equals to 1 per omega C. Okay, and you substitute the F and the reactance just now. So you get capacitance 1.00 times 10 to the power of negative 3 farad. Okay, so we stop now because we don't have time, but it's okay. The equation, we will discuss more. We finish already the whole chapter for SEM 2. So starting next week, we are going to do discussion on the question, past year's question. Okay, So I will post the past year's question earlier before we start the class starting next week lah. Okay, just wait for next week. Okay, I give back our session today to Madam Nun. Okay.
Okay, Alhamdulillah. Thank you so much, Madam Rosmaya. So we have reached the end of today's session. Congratulations to those can follow our session from the beginning till the end. Before we end our session for today, I will announce the last or the fourth digit code for the credit claim. So the digit is 5, number 5. Okay, take note. So you have complete 4 digit and 1 letter. So all of you, please stop posting your comment for a while. And if you haven't clicked the subscribe button yet, please do so. Make sure that it is turned to grey color, not the red color, okay? And activate the icon bell so that you will not miss the next class session. Then, if you find that the lesson was beneficial, click like and share to your friends on your social media. Spread and share the goodness, okay? So, once complete, type done on the chat box before the certificate link is given as a token of appreciation and token of thank you for your dedication in joining the free online class today. Okay, link for the certificate and link to claim credit are already given in the chat box, right? Please take note, the link will end half an hour after the live. Make sure to use the EDD email only to log in. Incorrect email use will not be entertained. So if you haven't got one, please apply. The link to apply the EDD email is also given in the check box. If you wish to get more information on the online classes, go to www.academyyoutuber.com, and to those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thank all students for joining our tuition class today. Remember that the more classes you join, the more credit you can claim. Feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all the teachers throughout Malaysia for all the students throughout the country. Thank you too for being a YouTuber Academy supporter too. So I think that's all for now. See you in another session. Do not forget the hashtag bermula percuma, selamanya percuma. Stay safe till we meet again next week at the same day and same time. Thank you so much and Assalamualaikum. Bye everyone. Do take care.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.